In this webcast, I just wanted to take a quick look at the Molmodac Primary Literature Collection, which is a collection of chemical literature articles that you can use to jumpstart the topic selection process. In the last webcast, we talked about a sort of what you might call top-down approach, where you start with a macroscopic effect in mind, and then you do research to arrive at what's known about the microscopic effect, or what we call the molecular mechanism involving organic compounds. What the primary literature collection can help you do is do the process of topic selection in reverse. So using and beginning with the microscopic process, the molecular mechanism, and building up to a macroscopic effect that is interesting or compelling. So in this webcast, we're going to work through one particular example of a paper in the primary literature collection that's currently unclaimed about an elimination reaction that has important implications for post-translational modification, which you'll see as we move forward. The title of the paper is The Molecular Mechanism of Elimination, which is a newly discovered post-translational modification. And the idea, which is pretty clearly shown by a figure in the paper, is that this enzyme catalyzes the elimination of phosphate from threonine residues that have been modified through phosphorylation. So, long story short, there are three possible mechanisms of elimination here, and this is a pretty nice Molmodac topic because it deals directly with the enzymatic elimination lesson, and experiments have been done to determine which of these three mechanisms is operative. And so, moving forward here, we might read through this paper, look for instance in the conclusion section where they pin down what the mechanism is. And in addition to doing this, one thing that we'll want to do, and that you'll want to do for your Molmodac topic as well, is look for references that dictate other aspects of the mechanism that are important, or the fundamental reasons why conclusions are drawn in a particular paper. So for instance, this particular study was a computational one that used quantum mechanical, molecular mechanical calculations. Kinetic isotope effects is the experimental evidence that really pins down the E1CB mechanism in this case, and so we can follow this paper for more information about that study. To move to the sort of macroscopic level, a good place to look is in the introduction. Usually within the first 2 or 3 sentences of a paper, they'll explain the broader implications of the study, and in this case we can see that post-translational modifications are a big part of this. So the enzyme catalyzes a post-translational modification of a polypeptide, and just a quick Google search reveals the importance of PTMs, for instance, in health and disease. So the primary literature collection, by claiming a paper here and reading through the literature here, can help you address the process of topic selection, again, from a micro level to the macro level. If you prefer doing this as opposed to the macro to the micro, which can sometimes be associated with quite a bit of uncertainty if you're going from the large to the small, then you can use the primary literature collection to jumpstart that process.